and it is not a theory dense chapter as we have seen in chemical bonding. Chemical bonding is typical completely theory based. Here you will be seeing numbers as we used to see numbers in the first chapter, very similar to those type of problems. And number of moles, these terms will be used in this chapter also, thermodynamics. Acha. Now let us see in the sequence of chapters. In the sequence of chapters we have done till now, where does thermodynamics lie? So when we talk about chemistry, we started with some basic concepts and techniques, because that was the language of chemistry that we wanted to understand. What is its grammar? What are the terms that we are generally using? Now, once we understood that, then we went directly towards the basic entity that is in chemistry, because in chemistry we generally study matter, right? We study matter and its change. If someone wants you to define chemistry, so chemistry is the study of matter and its change. Okay, so matter, it is made up of atoms. So after studying the language of chemistry, we directly went to atomic structure. Atomic structure. Now we spent a bit of time in atomic structure, talking about the history, how we came to know that what is proton, what is electron, where is its position and all. After that, we came to know about the electronic configuration, and electronic configuration was a big jump that it was telling me about the reactivity of different elements. So when we talked about the atomic structure and electronic configuration, then we arranged elements with their increasing atomic number. When we arranged them in their increasing atomic number, we found repetition because the electronic configuration were repeating. So after that, we went towards the chapter that is periodic table. So we made a table to predict the reactivity of different elements, and we classified, okay, fine, these elements they react similarly, these elements they react similarly. So we went to periodicity, periodic table. Now, after learning about periodic table, how different elements react and what properties lead them to react and however they react, then we went to talk about chemical bonding, because once two elements they react, they will obviously form a compound. And in a compound, we will be having two different atoms bonded together. They will be together always. So that is why we went towards chemical bonding. We went towards chemical bonding. Now, as we were ending the chemical bonding, we learned about weak forces, if you remember, van der Waals forces, hydrogen bonding, and metallic bonding, all of these things, these are weak forces. So when we learned about chemical bonding, so chemical bonding is talking only about one molecule. One molecule. Now, if we have different molecules, and when then different molecules they come together, for example, when I talk about water, then right now you may say that it is H2O, but in reality, what is water? Water is that liquidy thing that we have, right? So whatever chemistry is happening, it is happening in that liquidy thing, that is, we say pani or water, right? We don't know about H2O right now exactly. Now, whatever reaction will happen will be happening in that particular water. That is a bulk water. Now, when we talk about only H2O molecule, we are talking in the molecular level. So we understood everything about the molecular level, how the molecule is, what is its shape, what is its bond angle, and how it is reactive because of the presence of lone pair electrons on the oxygen atom, and hydrogen is delta positive. That is why it forms hydrogen bond. We studied everything about the molecular level. Now we will move towards the bulk phase. Bulk means when you bring millions and millions of water molecules, then it will form liquid. If you bring million and million of sodium chloride, it will form solid. If you have million and million atoms of helium, it will be gas. Hydrogen will be gas. And that is why the chapter which is not present for you guys is the states of matter. States of matter. But this is not there in your syllabus now. So we are not going to study states of matter in detail. We are not going to study states of matter in detail. But we can move on. And we understood that what states of matter was dealing with. Now, we're studying till here about matter. Now we will move on to the next part. Once we have studied matter, then only we can talk about its change. Correct, guys? Yes or no? Please tell me. Alia, Mariam, Yasir, and Sarah. Sahi hai?
Yes,
Till
sir.
here we were talking about matter. Now we will be studying about its change. Now that will be dealt with thermodynamics. That will be dealt by thermodynamics. Okay. Just give me a second, guys. Just need to forward some important things, then I will come back to you guys. So all of you understood the sequence, yes or no? Please tell me, of the chapters and why we are learning in this way, yes or no? Please tell me, guys.
Yes, sir. Yes, sir.
है ना? One second, questions were there. Now, since when we started talking about matter, we first of all understood a bit of language, you know, how we are going to speak about different things. So here also we will be starting with those basic terminologies and concepts. But if I talk about, Acha, whenever matter changes now, another thing that is you have to very much focus here. Whenever there is a change, it is accompanied by something that we know as energy. Some changes in energy also happen. When matter changes, so its constituent particles will change. When matter changes, its constituent particle will change, and it will be accompanied by some change in energy. For example, if I talk about dropping a pen, then it has some potential energy at the top, but as it is falling down, the potential energy is decreasing, kinetic energy is increasing. Now, when matter changes, it will always be accompanied by some kind of energy changes also. If not, if there is no net change in energy, for example, the total energy remains the same, right? Potential energy decreases, kinetic energy increases, and so on. So even if there is no net change, but at least some type of energy is getting converted to some other type of energy, right? And when we generally talk about energy, there are two things which can happen, है ना? So दो हादसे हो सकते हैं energy के साथ. There are two different types of accident which can happen with energy. First, what we can do, we can transfer energy from one body to another. Transfer of energy can take place. Another thing is transformation of energy that can take place. Transformation. Okay. Now, transfer of energy, again, as I said, potential energy to, no, sorry, transfer of energy is when you heat something. When you are heating something, then what is happening? It is going from hotter body to the colder body. That is transfer of energy. Transformation is conversion from potential to kinetic, electrical to light energy. All of these are transformation of energy. We will be also studying about transformation of energy, but that is in 12th standard. Chapter is electrochemistry. Chapter is electrochemistry. Okay. In electrochemistry, we will be dealing with chemical energy, which changes and it converts to electrical energy and vice versa. Right now, we are going to learn about the transfer of energy from one body to another. From one body to another. Okay? For example, if I talk about heating a particular container, then we are transferring energy, right? It is heating. And this particular chapter, thermodynamics. If you Sandhi, which maybe you must have learned in Hindi, if you break this, thermo, it means heat. Dynamics means flow, right? So the flow of heat is thermodynamics. The flow of heat is thermodynamics. Okay. So basically, we'll be learning about thermodynamics, and especially we'll be learning about thermochemistry. That means thermodynamics applied to chemistry. You also are learning thermodynamics in physics also. Did you start thermodynamics in physics? I don't think so. So I start with thermodynamics in physics.
Yes.
No, not right now. I think that will be done after the first term. Okay. Let us first of all write what is thermodynamics and everything, and then we can move on to the basic terminology. Okay, please write the branch of science which deals with the branch of science which deals with the study of different forms of energy, and their transfer from one body to another. Is called thermodynamics. Called thermodynamics. उसके बाद लिखिए basic terminology and concepts. Basic terminology and concepts. ठीक है. और आज के टाइम का सबसे फेवरेट वर्ड we are going to define, right? System. Number 1, system. Yeah, what is system? System is that specific part of the universe which is under observation. For example, in chemistry, if we are observing a flask, let us say, then that is the system. If we are observing a changes that is occurring in the test tube, that is the system. Okay, so system is the specific part in the universe or of the universe which is under observation. Meaning, either you are observing the temperature change, or either you are observing the color change. You must be doing some titration where you are observing color change, or what you are doing, you are observing some kind of pressure change, you are observing some kind of formation of precipitation. So if you, whatever you are observing, right, the part of the universe that you are observing, that is the system. That is the system. Please write a specific part of universe which is under observation. Is called a system. Called system. Now, system can be, system, you can classify it on the basis of many things, but on one of the basis is classified into two different parts, heterogeneous and homogeneous. System is classified into two different categories. First we have heterogeneous or homogeneous. ठीक है. Heterogeneous का meaning is the components of system have more than one phase. Phase का मतलब क्या हुआ? State है ना. Solid, liquid, gas, those are phases or state. Next is, please write, components of system component system have one and rather only one phase. Only one phase or state. One phase or state. समझ सबको है ना? ठीक है, फॉर चलिए कुछ सवाल दे देते हैं, क्लासिफाई कीजिए. Classify the following as heterogeneous or homogeneous. ठीक है, नंबर 1. Boiling of water. है ना? So we are observing boiling of water. So it will be homogeneous or heterogeneous. Then second, if I talk about block of iron, you know, maybe block of iron is getting heated or it is getting cooled down, something like that. We are observing that. Human body, you're observing changes in human body. Fourth लिख लीजिए pencil. Fifth लिख लीजिए glass of water. Sixth you can write juice. ठीक है, all of you understood ना? Yes or no? Tell me. Homogeneous, heterogeneous, है ना? आसान. If whatever you are observing, it has only one state. Whatever it is, whatever is present inside the system, it is only of solid state, then homo. Only liquid, then homo. Only gas, then it will be homogeneous. Otherwise, if it is having solid as well as gas, solid as well as liquid or something else, if it is having solid and anything else, liquid or gas, it will be heterogeneous. Okay. If it is different, then it will be heterogeneous. Same, then it will be homo. चलिए शुरू हो जाइए. And I will give you इसमें कितना 1 मिनट काफी होगा, 2 मिनट चलिए दे देता है आप लोग को. 2 मिनट गाइस, 2 मिनट काफी होना चाहिए आपके लिए. Send your answers on my WhatsApp, guys. Send your answer on my WhatsApp. Send your answers on my WhatsApp. Yasir Hassan. सलाम सारा आंसर भेजिए आप सलाम तो कर लिया आपसे हमने पहले ही ठीक है fine. Others please send Alia and Mariam. Mariam, you understood yes or no?
Yes, sir.
जल्दी भेजिए प्लीज क्या पेन यूज कर रहे हैं आप यू आर नॉट राइटिंग नोट्स और व्हाट हाँ मरियम
Sir, I wrote this in an exercise paper.
you write this with this pen
No, only this. Because
only
I
what
have to send.
because you have to send you have written with this डराने के लिए हम okay हम सवाल भूल गए सवाल क्या था भाई बॉइलिंग ब्लॉक ऑफ आयरन बॉइलिंग अच्छा ब्लॉक ऑफ आयरन अरे थर्ड है ठीक है फोर्थ है अच्छा ठीक है चलिए मान लिया आपकी बात 5 और 6 चलिए ठीक है अच्छा बात करते हैं ठीक है ना एक सेकेंड लेट मी सी आलियास ठीक है जस्ट गिव मी अ सेकेंड गाइस तो चलिए ठीक है बॉइलिंग ऑफ वाटर में सी हियर गाइस मरियम आपने कुछ अजीब आंसर लिखे ठीक है ना एक सेकंड देखिए बॉइलिंग ऑफ वाटर इज व्हाट इट इज बॉइलिंग ना बॉइलिंग में यू हैव लिक्विड आल्सो if it is boiling you have vapor also if I'm observing boiling of water then obviously what I'm doing I'm observing liquid as well as vapor so it will be hetero got it yes or no ये तो शायद आपने सही लिखा है उसके बाद block of iron मरियम why it is hetero yes Miriam
It's homogeneous.
so why you have written hetero see
I got confused.
got confused about what show me where you have written this part did you write this
Yes, sir.
show me so block of iron is only one block of iron इसमें क्या होगा it will be homo अच्छा आलिया our human body it contains each and everything we are breathing so lungs our lungs contain gas right air blood contains liquid blood is liquid so water and everything else like skeleton and everything these are solid so it will be what hetero right
I was going to write hetero, then I was like, okay, I took my guess on homo then.
No problem. Okay, pencil, it will be obviously homo. If it would have been pen, then pen obviously it has ink also, so it would have been hetero. Glass of water is a tricky case because in this we have written glass of water, so I'm observing this whole thing. I'm not just observing water, I'm also observing the glass in which the water is present. Then what do I can say? I can say that it is hetero. Right? So it is a glass of water which I'm observing. Yeah? Juice, it is on your decision whether you like the pulp. If you like the pulp, right? Some juice they contain pulp and some they don't contain pulp, right? So pulp will be hetero. And if you did not consider pulp, then it would be homo. So both the answers are right. No matter. Now, obviously, there will be no question from this part because this is just introduction to the thinking in terms of thermodynamics, that what is system and hetero and homo, all of these things. Okay. Moving on. No matter if you did it wrong, it can be corrected very easily. बहुत ज़्यादा concept नहीं बिगड़ेगा. ध्यान से अब अगली चीज़ देखते हैं. ठीक है ना? I hope everything is clear. Mariam, still waiting. Send me now. What you've written about the system, please send me. देखिए 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 आपने क्या लिखा मरियम, टाइप ऑफ मिक्सचर्स. इससे पहले का वीडियो नोट, इससे पहले आपने क्या लिखा है?
I didn't write that, sir.
Why you did not write that? ये भी आपने अभी लिखा है ऐसा लग रहा है. Once I told you to send me.
I wrote this half, and then you asked the question, so I was doing that.
ठीक है. So you will tell me, sir, wait a second. Now, see, please write the notes, okay, Mariam?
Yes,
If
sir.
you have to write. You have not written this. The meaning of system also. Each and everything is important. No, I am not writing just for fun here, no.
Yes, sir.
Important है तभी हम लिख रहे हैं. And I obviously tell, see, हमने ये तो नहीं लिखा ना ये सारी चीजें note down करें, because I know that if you are keeping this in notes, there is no use of that. But notes का purpose, though there are two purposes of notes. First, when you write it as well as you are listening it, then there are two sensory modes that are active right now, right? First you are listening and then input as well as output is present, right? And if you are speaking also, and if you're understanding those terms also, then it is three sensory modes. So first thing is that. Another thing is I give notes for you to revise. मेरा main purpose ये होता है, once you come back to the notes, you should understand each and every topic that I am teaching, है ना? So if you give my notes to anyone, they can understand these notes also. I try to write each and everything that I speak, है ना? जहां तक भी हो सके जो चीज याद रखने वाली है वो सारी चीजें हम क्या कर सकते हैं? I would put that in your notes. So please write each and everything, okay? Basically it is for the revision because I will not be present, है ना? So I write notes in such a way that even if I am not present with you, then also you can understand whatever it is written. Okay, so don't be lazy, please write notes. Moving on, I hope you will obey this advice, है ना? ये तो advice ही है, otherwise कुछ तो कर नहीं सकते. कल मेरी एक अपने टीचर से बात हो रही थी, like he taught me, just give me a second, just give me a second. After this, we will talk about surrounding. Okay, so please write. We have written system. Second is surrounding. ठीक है, जल्दी अब थोड़ा सा फास्ट लिखेंगे, हल्की हल्की चीजें हैं बस. What is surrounding? The remaining portion of the universe the universe, which is not part of, which is not the part of system. Okay, so what is surrounding? So if we imagine this is our universe, and if we are having this small portion, which is under observation, this is small portion, this is under observation, meaning this is the system, then the rest of the part, it is surrounding. You know, whatever is away, this is system, this is surrounding. And this blue part, so the area which separates the system and surrounding, it is known as boundary. And this part is the system. Okay. Next, right, please, right. System, and this whole thing is universe, by the way. No? This whole thing is universe. System and surrounding. System surrounding are separated by boundary. Separated by boundary. Moving on. Now, obviously, boundary can be of two types. If we talk about a real or imaginary boundary. So boundary can be real or imaginary. Boundary can be real or imaginary. Okay. Boundary can be real or imaginary. Now, on the basis of type of boundary, the boundary real and imaginary. You know? So there can be further types of boundary. And on depending on the type of boundary, we can further divide system into 3 types. These are very important. And इसको ध्यान से देखिएगा आप लोग. We can divide system into 3 types. Please write. Open system, closed system, and isolated system. ठीक है, यहाँ सवाल आएगा आपका. ठीक है, ध्यान रखिए. Open system, closed and isolated. Now, what is open system? In open system, what can happen? Matter and energy both can be exchanged. Matter and energy both can be exchanged between system and surrounding. Between system and surrounding. For example, you have open bucket, you have open utensil, right, etc. All of these are example of what? Open system. In closed system, what will happen? You can exchange the matter. Sorry, you cannot exchange the matter, but the exchange of energy is possible. Huh? Please write. Exchange of only energy is possible. Only energy is possible. For example, you will have, if you have sealed bottle, Okay, if you have steel bottle, the steel bottle can get hot or cold. If you keep it in fridge, it will become cold. So obviously there is an exchange of energy. Then this will contain, it contains diathermic, it contains diathermic wall or boundary. Okay, diathermic means it can conduct heat. So that type of boundary is present. Huh? And if you have covered some utensil and you are heating it, then obviously it is a closed system in which you cannot put any matter or matter cannot be exchanged, but energy can be exchanged. In the last third case, isolated, you can't exchange matter or energy. Energy, neither energy nor matter can exchange. Neither energy nor matter can exchange. For example, you have vacuum flask. I think vacuum has a single C. You have vacuum flask. Another example would be by the way, this contains adiabatic wall. Okay, we call it adiabatic wall. Adiabatic, है ना? A मतलब not happening. Adiabatic wall. But we call it adiabatic wall. Okay, adiabatic wall or boundary. ठीक है? Now, if you have written this, then please see. If I talk about boundary, then boundary can be classified on 3 different bases. Please see here, guys. If I talk about the existence of a boundary, if I talk about existence of a boundary, then boundary can be classified into 2 types, real or imaginary. Okay. If I classify on the basis of heat exchange, then it can be classified into 2 types. It will be either diathermic, which conducts heat, or it will be adiabatic, which does not conduct heat. Adiabatic, which does not conduct heat. And if I classify this on the basis of flexibility, then it can either be rigid. So for example, if you have box type of thing, or it can be flexible. Flexible means you have some kind of piston here, and this piston can be moved up or down. So we can classify boundary in these different manners. Please let me know if you have any doubt till here. You're done writing? Then. By the way, can we move on, guys? Are all of you done writing?
Yes, sir.
ठीक है, चलिए. We have defined matter, we have defined boundary, we have defined surrounding, we have defined system. Now, when we are talking about changes, please understand this very clearly. When we are talking about changes, तो बताइए what things can change? Tell me guys. Alia, Mariam, Yasir, Sara. है ना? I have initial phase and then I have the final phase, है ना? And there some changes are happening, right? Whenever a change happens, there will be an initial phase and a final phase. Correct है guys? Yes or no? Please tell me. चलिए,
Yes, sir.
थोड़ा सा आप लोग कोशिश करके बताइए what can change. For example, कुछ change बताइए आप.
Size.
Size can change. जैसे size किस चीज का change होता है? For example, सारा.
Ice cube after melting.
Ice cube after melting. ठीक है, तो ice cube after melting अगर हम उसको अच्छे से क्लासिफाई करें तो वहां पे फेज चेंज हो रहा है, और अगर हम देखें तो उसमें टेम्परेचर चेंज हो रहा है, राइट सारा?
Yes, sir.
है ना? सो वी विल मूव टुवर्ड्स साइंटिफिक लैंग्वेज. ओके फाइन, ठीक है. सो टेम्परेचर
Yes,
वुड बी अ better word to describe the change, right? So you had H2O, that was your substance. It was 0 degree Celsius. Now it is at 3 degree, 4 degree, 5 degree, 6 degree Celsius, right? So temperature is changing. Temperature हो गया. और कुछ बताएं? Temperature can change. What else can change?
State.
State can change. Okay. But state is a function of temperature, right? So I don't want to write two things at the same time. है ना? State is a function of temperature, right? I mean, if you are going to change the temperature, the state is going to change. So state is inside the temperature itself, right? Sara, correct है?
Yes, sir.
अगर हम state को हटा दे तो कोई दिक्कत नहीं ना, because it is already included. It is an effect, I would say, है ना? It is an effect, I would say, that when temperature changes, the state changes, है ना? Anything else? Anything else, guys? Anything else?
Volume.
Volume can change. Very good. और बताइए, what else can change? Pressure can change. Very good, Alia. Yasir, कुछ आप भी बताइए. मरियम, आप भी कुछ बताइए. Mariam, Yasir, guys, tell me something. What else can change? Time can change. Time किसी चीज का चेंज नहीं होता, मतलब लोगों का ऐसे वक्त बदलता है, बट टाइम इज, मतलब किसी आइटम, किसी चीज का टाइम नहीं चेंज होता ना. ठीक है, टाइम चेंज होता है, बात सही बोलता है, बट किसी चीज का टाइम नहीं चेंज होता. प्रॉपर्टी नहीं है, किसी एक ऑब्जेक्ट की प्रॉपर्टी नहीं है टाइम, है ना? So if you see here, we are talking generally about the property which is changing. Correct, guys? Yes or no? Please tell me.
Yes, sir.
Right. So we have to now learn about the different properties that can be present. Different properties that can be present. Acha. Now all of these are, see, we have talked about a few properties. For example, bond angle of water, bond angle of NH3. These are properties. Yes, correct, guys? Bond angle of CH4. है ना? Bond order, bond angle, all of these are also properties, right? We have just learned these things. Correct, Alia, Mariam, Yasir, and Sara?
Yes, sir.
But we are not talking about these when we talk about changes, right? Because when we study, there are two different types of properties, है ना? ध्यान से अब देखिए, ये scientific language अब आप लोग के अंदर आ जानी चाहिए. Once you have done intermediate in science, intermediate of science you will be, right? That means intermediate, na, +2. I mean, class 12th is intermediate. Class 10th is matriculation. Class 12th is intermediate of science. And even if you come to India, people talk in these terms, ISC. After ISC, you do BSc. After BSc, you do MSc, right? So once you have done the intermediate of science, you should be at least be able to understand scientific terms and think about things scientifically, है ना? तो नॉन साइंटिफिक वे में नहीं, उसको अच्छे से ऑर्गेनाइज करते हुए and be very, what I can say, precise about your words, what you're trying to say, है ना? At least in the domain of science. बाकी आप दोस्तों के साथ जो करें उससे कोई मतलब नहीं, but at least in the domain of science, to be a bit cautious. ठीक है? So what we are saying that there are properties. The properties are of two types. So these bond angle we have discussed in the last chapter, bond order we have discussed, the hybridization, bond angle, bond order, hybridization, right? All of these things, these are what? These are microscopic properties. Microscopic properties. Now, what we are going to study, these temperature, volume, density, number of moles, boiling point, melting point, pressure, all of these things, these are macroscopic properties. So these are also known as bulk properties. Okay. So macroscopic properties are of bulk. One atom will never have a boiling point. One atom will never have any temperature. एक चीज का टेम्परेचर हो ही नहीं सकता है. One atom can neither be liquid, solid or gas. है ना? उसके phase हो ही नहीं सकते. If I am talking about solid, then the definition of solid says that when the atoms are nearby. As soon as I said atoms or particles are nearby, and obviously it will be plural. So one atom, all of these things could not be in any state. Okay. So that is why we'll be only talking about in this class, because we are going to learn about changes and we are going to observe changes in the macroscopic world. We are not microscopic entity, so we cannot see what changes are happening exactly in the microscopic world. But yeah, for sure, looking at macroscopic, we can infer what is happening in the microscopic world, and that is the purpose of chemistry. Changes that are occurring in the macroscopic world, how to relate them in towards the microscopic level, to the atomic level. We do not see atoms, but there are some changes which are happening in the macro state, which tells us about the atoms, which tell us about that nitrogen has 7 protons, 7 electrons. Okay. So see here, right next, macroscopic properties. Macroscopic properties. Now, macroscopic properties can be divided into two different types. Yeah. Here, guys, macroscopic properties are of two different types. One are known as extensive property. And the other one is known as intensive property. Intensive property. What is extensive property? Is right. This depends on the amount or mass of substance. This depends, or rather I should say does not depend. The amount or mass of substance. है ना? जैसे, for example, when I am talking about if mass, है ना? Mass depend on mass or substance. For example, number of moles. So if mass will increase, number of moles will also increase. Okay? Similarly, when I talk about volume, if you increase the mass of a substance, its volume will also increase, right? Okay? But intensive property, for example, if I talk about density, density, no matter how much iron you are taking, no matter how much water you are taking 10 ml of water or 100 ml of water, the density of water will be the same. Similarly, melting point and boiling point. So if you are taking 1 gallon of water or you're taking 1 tank of water, its boiling point will be 100 degrees Celsius, its melting point will be 0 degrees Celsius. Okay? Or freezing point will be 0 degrees Celsius. So all of these things are what? Extensive, or either it is intensive property. All of you understood the difference? Yes or no, please tell me.
Yes, sir.
Between these, ठीक है, सवाल लिख लीजिए. Classify. These are important now. Okay, यहाँ सब सवाल आते हैं. Classify the following. as extensive or intensive? A, mass. तो मास तो ऑब्वियसली मास पे डिपेंड करेगा, राइट? बी पार्ट। मरियम लिख रहे हैं ना आप? हाँ मरियम,
Yes, sir.
वेरी गुड। वॉल्यूम, P part, please write density, D में लिखिएगा नंबर ऑफ मोल्स, E में लिखिएगा टेम्परेचर ना, यू विल जस्ट से मास पे डिपेंड करता है यानी, ओके, वेदर इट डिपेंड ऑन मास और बॉइलिंग पॉइंट, मेल्टिंग पॉइंट, ठीक है, इतना लिखिए। फिर देयर आर टू एग्जांपल्स दैट आई विल, ठीक है, टेक 2 मिनट फॉर दिस। 2 मिनट कम हो जा रहा है तो 3 मिनट दे देते हैं आप लोग को। टेक 3 मिनट्स, सेंड योर आंसर ऑन माई व्हाट्सएप, सेंड योर आंसर ऑन माई व्हाट्सएप। Time is over, guys. Send your answers, please. Yeah, very good, Sarah. Everything is correct. Mariam, Alia, Yasir, you are not even interacting now, है ना? आप कोई आंसर भेज रहे हैं? नहीं नहीं, आपने भेजा तो शायद चैट में भेजा था ना आपने आंसर? Yeah, you sent on chat, I guess. ठीक है, चैट में भेजिए आप इसका भी फिर। You're sending in the chat. Mariam, looking at your answer, correct. ठीक है, सही है, very good, very good, correct. Alia, looking at your answer now. Correct. Very good. चलिए, अब एक थोड़ा सा आपके पास there is a, अच्छा इसको हम आंसर लिख देते हैं पीसी है. This will be extensive, this will be extensive, this will be intensive because density will not change by mass, and जैसे जैसे mass बढ़ेगा वैसे वैसे volume भी, that is why density will not increase. Number of moles, obviously it is going to be extensive, temperature intensive, boiling point intensive, and melting point will be intensive. Now I am giving you two different situations, जरा उसके बारे में सोचिए, ठीक है. Let us suppose I am having a flexible boundary. Okay, this is not rigid, this is flexible. This can go up and down. This is flexible boundary. Now tell me, let us suppose we were having some moles of gas here. Okay, so these moles of gas, they will apply pressure on the walls of the piston, and maybe the piston will move up or down, and according to whatever the pressure is, so it will move up or down, however it is going to move. If I am going to add, because it is movable, if I am going to add more and more amount of gas particles, more and more amount of gas molecules here, then what is going to happen? The piston will be moving up because what is happening? Because the gas particles are applying pressure. It will moving up and down, right? But what will happen if it moves up? If it is moving up, the volume is increasing. If it is moving up, the volume is increasing. And as the volume increases, the initial pressure will be again, whatever the pressure initially it was, it will be again, the same pressure will be afterwards when the gas particles, they did some work and they lifted the piston up. So there was some increase in pressure. So that increase in pressure will be balanced out, because they have increased, because what they have done, they have lifted the piston up. So that particular pressure is now balanced once again. So initially it was 10, I added some more moles, then it increased from 10 atm to maybe, let us suppose, 15 atm. Now as it increased to 15 atm, when the pressure is more, then the piston will be lifted up. When the piston is lifted upwards, then what is going to happen? The pressure is going to decrease. The pressure is going to decrease. Now this is case of flexible boundary. If I have a rigid boundary and I apply more and more amount of gas, the gas has nowhere to go but to apply more and more pressure. And the pressure will also increase as I increase the mass of the gas. So in the case of pressure, there is a nuance here in the case of pressure. So if you have pressure and the boundary is flexible boundary, pressure, and you have flexible boundary, then obviously if you add more and more mass, the flexible boundary will increase the volume. It will increase the volume and it will be equating, or it will balance out the pressure. That is why it will not change. That means it is intensive. But if I measure pressure in rigid boundary, then it is going to be obviously extensive because the pressure will increase as I am adding more and more gas molecules. Okay? So please write this down. Let me know once you're done. चलिए, now once you're done, आप एक बात बताएंगे हमको, ठीक है ना? Will tell me something. In this chapter, now once we have talked about different types of properties and all, we'll be talking about initial state. There will be some change happening, which will lead to the final state. And between whatever, from initial to final, there will be some process or some change happening. Okay, process or change happening. And this chapter is going to deal with this change or this process or this process and this change. Okay. So this is what we are talking about today. Not today. I mean, this complete chapter, thermodynamics, is only and only about process and whatever changes is happening, process or change. So initial and final is there obviously, but we are mainly talking about the process here. We are mainly talking about the different types of process. Fine. Let us suppose I am starting with a block of ice, and this block of ice is 100 degrees Celsius. A, and this block of ice here, not block of ice, sorry, my bad, block of iron. And ice कैसे 100 degrees हो सकता है? Block of iron, this is B block, and it is 0 degrees Celsius. 0 degrees Celsius. Now there are few options. Let us suppose I made them in contact with each other. I brought them in contact with each other. Now A and B, both of these blocks are in contact. So I have A and B. So what do you think what is going to happen? Will the temperature of A and B, will the temperature of A and B both increase? Or second option, the temperature of A increases, or rather I should say both decrease. एक ऑप्शन दे देते हैं आपको, क्या A और B के टेम्परेचर में बोथ, सो दोनों में क्या आ जाएगा, डिक्रीज आ जाएगा. और थर्ड ऑप्शन इज, लेट अस सपोज A will increase and B will decrease. Or the fourth option, the temperature of A will decrease and B will increase. Send your answers on the chat. 1, 2, 3, 4. What I am doing, I am bringing these two blocks of iron in contact with each other. So right now they are not in contact, but if I bring both of them into contact, then what is going to happen? Both the temperature will increase, A and B, both the temperature will decrease, or the temperature of A block will increase, the B block will decrease, or the temperature of A block will decrease and the temperature of B block will decrease. Sorry, B block will increase. Simple है, बताइए जरा. I hope it is not very hard. Not very hard. Yeah, correct, Sarah. Very good, very good. Yes, yes. Simple, very logical. Okay. Please answer, everyone. Mariam and Yasir, all of you guys, please answer. Alia correct, Sarah correct. Yasir, Mariam, you have no answer. Yes, Mariam, you have no answer. Mariam, logically तो कैसे थोड़ा आप बताइए कैसे increase करेगा? Have you never touched a hot thing or a cold thing? थोड़ा तो सोचिए ना. You please listen to what I am saying and try to answer in that way. आपने तुक्का मार दिया. You have just answered anything. What did I ask, Mariam? Can you tell me at least that? What did I ask?
If the blocks are in contact, then will the temperature increase or decrease?
And these are the options. So what do you think? What will happen? Which is hot, A or B? Which is hotter?
A.
Okay, so if you have a hot thing and it comes into contact with a cold thing, what happens to the cold thing?
It becomes hot.
It becomes hot. And what happens to the hot thing? Listen, I mean, try to think about it like this. There is a cold thing and you bring some hot thing towards it. What happens to the hot thing?
It becomes cold.
So what will happen? A will become colder or hotter?
It will become colder.
So temperature will increase or decrease?
Decrease.
Okay. And what will happen to B? It will become hotter or colder?
It will become hotter.
So its temperature will increase or decrease.
Increase.
So tell me what is the option?
4. The fourth one.
Fourth one, yeah. So your answer is also correct. Fourth one, right? Okay, so at least you're on this phase. Fine. So see, as we talked about temperatures, and as we talked about temperatures. Now, if you see here, please, we will be talking about, as I said, initial and final states. Initial state of the system and final state of the system. Now, please remember, when we talked about iron, the iron block, we could have talked about many different things. है ना? बहुत ध्यान से सुनिएगा, बहुत important बात है. You will not find this anywhere, okay? You will not find this in books, है ना? So ये चीजें किताबों में आपको नहीं मिलेगी. How to study thermodynamics, है ना? If you go to thermodynamics, the history of thermodynamics is very dark. Whoever studied thermodynamics, and one of the major person was Boltzmann. He killed himself. ठीक है? So thermodynamics is a very dark subject. हाँ, सही बात है. आपको झूठ लग रहा है? झूठ लग रहा है, देखिए इनको. Just a second. आपको लग रहा है मजाक कर रहा है. ओह, so small. हाँ, चलिए पढ़िए जरा. क्या पढ़िए? Ludwig Boltzmann, who spent much of his life studying statistical mechanics. Basically, it is thermodynamics only. Thermodynamics and statistical mechanics, है ना? पहले thermodynamics पढ़िएगा, उसके बाद ही आप statistical mechanics पे जा सकते हैं, ठीक है? So, studying mechanics, what happened? He died 1907 by his own hand. Paul Ehrenfest, carrying on similar work, died in 1933. Now it is our turn to study statistical mechanics. ठीक है, तो मजाक नहीं कर रहे हैं यहाँ पे, ठीक है? So those who study, जिन्होंने पढ़ा है, everyone had same fate. Everyone had same fate. ठीक है, ध्यान सुनो. तो यहाँ पे चीजें बताने वाली, क्या बताने वाली सुनो. Whenever we talk about thermodynamics, we will be talking about process and change. A process or a change will be happening from initial to final state. Initial to Alia, Mariam, Yasir, and Sarah. Initial to
Final state.
Final state. Very good. Initial to final state. When we were talking about this metal block, please try to understand. When we were talking about this metal block, we could have told about its so many properties were there now. I just said metal block. I did not, I said iron block. It is right. I said iron block. We could have talked about its melting point. We could have talked about its mass. We could have talked about the volume it is occupying. We would have talked about its number of moles, but we did not. We only talked about 100 degrees Celsius. So even though this metal, the iron block, it has too many properties, but right now when we are defining this metal block, we are only interested in 100 degrees Celsius. Maybe in some other experiment, we will be discussing its mass, its moles, its volume. But right now we are only concerned about 100 degrees Celsius, and we are defining the initial state of these iron block as with respect to what? With respect to temperature. So now obviously one more thing, please understand. Temperature is a property which is changing from initial to final state. Temperature is the property which is changing from initial state to final state. And we are using, because if it is changing, it is varying. So it is obviously a variable. And we are using this variable to define a state. We are using the temperature to define a state. All of you understood? Yes or no? Please tell me. What are we doing?
Yes,
we are
sir.
using temperature as a variable to define what? To define a state. To define the state. Initial state 100. Final may A will decrease, B will increase. And the temperature of A will decrease and the B will increase. So we're defining the states on the basis of temperature. And that is why there are, depending on like all the properties. If you took some other experiment, we would have defined state in a different property. So all the properties can be variable. All the properties can be variable, but the variables which are used to define, or the property which are used to define the state, they are known as state variables. They are known as what? They are known as state. This is very important. लोग लगता है सर प्रॉपर्टी और स्टेट वेरिएबल में फर्क क्या है? So फर्क कुछ नहीं दोनों में. Each and every state variable will be a property. Each and every state variable will be a property, but all the properties cannot be state variable. है ना? We cannot start with all the properties of a particular thing of the system, and we cannot check all the properties of a system. We can choose. Okay. So obviously, when we are heating something, and phase change is not happening, we are only observing the change in temperature. So I will be only seeing the change in temperature. If we are doing some kind of reaction, there will be changes in the species altogether. There will be changing in the mass. So we will be talking about mass there. But so that is why what is going to happen? What is going to happen? State variables are those properties that define the state of a system. These are called what? These are called state variables. Please write next part, which is very important. स्टेट वेरिएबल्स. बिल्कुल एक एक चीजों को अच्छे से पढ़ते हुए चलिए. थर्मोडायनेमिक्स में आपने देखा ना अभी क्या होता है? देखा कि नहीं देखा आपने क्या होता है थर्मोडायनेमिक्स पढ़ने वालों के साथ? अरे आलिया, मरियम, यासिर एंड सारा देखा आपने?
यस सर.
है ना? तो ध्यान से, बिल्कुल एकदम ध्यान से चलिएगा. ठीक है, चलिए. स्टेट वेरिएबल क्या होता है? स्टेट वेरिएबल एक एक चीज को बिल्कुल छोड़ना नहीं है, किसी चीज को. आप लोगों के अंदर एक मतलब मेरा एक कजन है ना, उसने हिफ्स किया. ठीक है, उसने हिफ्स किया. इट टुक हिम अ लॉन्ग पीरियड टू लाइक कंप्लीटली मेमोराइज द कुरान. और अब वो मतलब नॉर्मल बैक टू स्कूल है वो. ठीक है, हिफ्स करने के बाद कुरान कंप्लीट मतलब पूरा मुकम्मल याद करने के बाद उसके अंदर एक चीज जो हमने बहुत बड़ा चेंज देखा ना, वो ये था, मतलब आई थिंक इट हैज ओनली बीन डेवलप्ड बिकॉज ही हैज कंप्लीटेड हिज हिफ्स. वो बाकी चीजें सब लोग देखते हैं ना, कि जैसे याद करने की पावर बढ़ जाती है ना, the memorizing power increases, है ना. Also their mind is open now because they have the Quran in their hearts, right? All of these things are present. But एक जो attitude में उसका change देखा ना, वो छोड़ता कुछ नहीं. मतलब आप समझिए, अगर आपने कुरान को हिफ्स किया है तो आपने जब तक पूरा कुरान हिफ्स नहीं किया तब तक आपने कुरान हिफ्स किया नहीं है. अगर आपके पास सूर्य नास छूटी हुई है आपकी ना, यही सूर्य नास छोटी सी सूरत है जो सबसे पहले याद हो जाती है, लेकिन अगर सूर्य नास आखिरी सूरह भी छूटी हुई है तब भी आपने पूरा कुरान हिफ्स नहीं किया. ठीक है, तो अब जब वो चैप्टर कंप्लीट करता है ना, तो उसके लिए कंप्लीशन का डेफिनेशन आप लोग के लिए कंप्लीशन क्या है? एक टॉपिक भी छोड़ दिया तो वो चैप्टर कंप्लीट है. हाँ या ना? आलिया, मरियम, यासिर एंड सारा, सही बात है. अगर कोई टॉपिक थोड़ा सा छोड़ दिया, एक सवाल समझ में नहीं आया मान लीजिए, है ना, चैप्टर 1 का एक सवाल समझ में नहीं आया, सही है, तो चैप्टर फिर भी तो हो गया आपके लिए. हाँ ना, बताएं. मरियम, आलिया एंड सारा.
यस सर.
लेकिन उसके लिए नहीं हुआ चैप्टर. उसका एक सवाल भी अगर छूटा हुआ है तो वो चैप्टर कंप्लीट नहीं है उसका. सो आई थिंक दैट इज समथिंग जो हर किसी के अंदर हो जाने से ना बहुत फायदा है. आप इस चीज को लेके आ जाइए कि मतलब ये चेंज हमको तो ये लगता है कि कुरान जब तक आपने पूरा नहीं किया तब तक पूरा हुआ ही नहीं. उसके लिए कंप्लीशन का डेफिनेशन ही चेंज हो गया. सब कुछ हो जाना चाहिए. इफ एवरीथिंग इज कंप्लीट देन ओनली तभी हुई है तैयारी. ठीक है, एंड आई थिंक जो टॉपर्स होते हैं ना, उनका भी एटीट्यूड ऐसे ही रहता है. अगर एक सवाल भी छूटा हुआ है, कोई एक वर्ड भी समझ में नहीं आ रहा है, तब भी वो बोलते हैं ना, नहीं यार ये चैप्टर नहीं हुआ. उनके मुंह से ही निकलता है. भले ही वो मार्क्स ले आए, मतलब 20 में वो 18 ले आएंगे, 19 ले आएंगे, 100 में वो 90 ले आएंगे, लेकिन उनसे तैयारी के बारे में पूछेंगे, यार ये चैप्टर नहीं हुआ. तो उनका मतलब रहता है चैप्टर का एक सवाल नहीं हुआ है. ठीक है, मैक्सिमम चैप्टर हो चुका है, चैप्टर का एक सवाल नहीं हुआ है. ठीक है, तो वो आप लोग थोड़ा एटीट्यूड चेंज कीजिए कि कोई चीज नहीं छोड़नी है. ठीक है, हसन मारी सबको, आलिया, मरियम, यासिर, सारा, आया ना?
यस सर.
चलिए ठीक है. सो व्हाट इज स्टेट वेरिएबल? सो अभी हम लोगों ने देखा प्रॉपर्टीज. सो दीज आर व्हाट? दीज आर प्रॉपर्टीज ओनली. दोस properties that define the state of a system. The state of a system are called state variables. Are called state variables. All of you understood this? Yes or no? Please tell me.
Yes, sir.
ठीक है, अब सुनिए इसको और हम थोड़े सा अच्छे तरीके से समझते हैं, ठीक है ना, बहुत अच्छे तरीके से समझते हैं। ठीक है, मान लीजिए आपके पास लेट अस सपोज यू हैव अ कप लाइक दिस। ठीक है, इन दिस कप क्या पीते हैं आप लोग, कॉफी या चाय? जल्दी बताएं, कॉफी और चाय क्या चाहिए आप लोग? सारा क्या चाहिए?
कॉफी।
कॉफी चाहिए, चलिए ठीक है, चलिए तो कॉफी आ गया इसमें, है ना, जिसने बोल दिया उसी से आ गई। ठीक है, कॉफी रख दिया इसमें, ठीक है ना, कॉफी रख दिया। मान लीजिए कॉफी बहुत ज्यादा गर्म है, 60 डिग्री सेल्सियस इस टाइम, है ना, लेट अस सपोज, केमिस्ट है ना, तो 60 डिग्री सेल्सियस, और आई थिंक 250 ml विल बी एनफ। हॉट कॉफी है, कोल्ड कॉफी नहीं, कोल्ड कॉफी थोड़ा ज्यादा ही पी सकते हैं, है ना, 250 ml विल बी एनफ, है ना। अच्छा, लेट अस सपोज आफ्टर 20 minutes, what happened, the temperature of this cold coffee will obviously decrease। ठीक है ना, क्या हो गया, डिक्रीज कर गया। फॉर एग्जाम्पल 20 मिनट्स के बाद ये क्या हो गया, 25 डिग्री सेल्सियस। बट आपने जब वॉल्यूम देखा, वॉल्यूम भी बढ़ा हुआ है। वॉल्यूम, इट इज हाउ मच, वॉल्यूम कितना हो चुका है आपका, मान लीजिए वॉल्यूम इसमें हो चुका है 300 डिग्री सेल्सियस, सॉरी 300 ml। ठीक है, वॉल्यूम बढ़ गया है। दूसरा एक सिनेरियो लेते हैं, है ना, मल्टीवर्स में है आप, है ना, स्पाइडरमैन का ना, स्पाइडर वर्स वैसे मल्टीवर्स में। तो एक यूनिवर्स में क्या हुआ आपके साथ, इन वन यूनिवर्स आफ्टर 20 मिनट्स, आफ्टर 20 मिनट 25 डिग्री सेल्सियस एंड 300 ml। ठीक है, अच्छा, दूसरे यूनिवर्स में 20 minutes, and after 20 minutes what happened, the temperature was, in this case the temperature was 40 degree celsius, 40 degree celsius, but जो यहाँ पे वॉल्यूम था, वॉल्यूम इज नाउ 100 ml, कॉफी कम हो गया। ठीक है, अच्छा, उसके साथ साथ यहाँ पे आपने क्या देखा, इन द 300 ml यूनिवर्स यू सॉ योर सिस्टर आल्सो, है ना, योर सिस्टर इज आल्सो इन द रूम, योर सिस्टर इज देयर इन द रूम। ठीक है, दूसरे यूनिवर्स में आपकी सिस्टर नहीं, साथ में आपका बिल्ली है, यू हैव अ कैट, यू हैव अ कैट। ठीक है, अच्छा देखिए, in both the universes we have defined the initial and the final states with different types of what, with different types of variables। temperature एक वेरिएबल है, वॉल्यूम दूसरा वेरिएबल है ना। both of these are important why, because both of them are changing। सही है, हाना, आलिया, मरियम, यासिर, सारा, करेक्ट है गाइस।
Yes, sir.
अब आपको समझ में आ गया होगा कि हुआ क्या है, यू सॉ द इनिशियल, यू सॉ द फाइनल, आपको प्रोसेस समझ में आ गया होगा क्या हुआ बीच में, हाँ या ना बताएं, सही है नहीं सही है, समझ में आया कि नहीं आया,
Yes.
क्या हुआ बताइए। पहले केस में क्या हो गया बताइए जरा, जहां पे आपकी बहन है वहां पे क्या हुआ, प्रोसेस क्या हुआ, आपकी बहन ने ठंडा पानी डाल दिया, तभी तो 300 ml हो गया और टेम्परेचर काफी कम हो गया। सही बात है, आया ना, आलिया, मरियम, यासिर, सारा।
Yes, sir.
Yes, sir.
ठीक है, दूसरे केस में क्या हुआ, बिल्ली ने क्या कर लिया, है ना, 20 मिनट में टेम्परेचर थोड़ा सा डाउन हुआ, दैट इज 40 डिग्री, बट लेकिन वॉल्यूम कैसे कम हुआ, बिल्ली ने आपका कॉफी पी लिया। सही है, और समझ में आ रही है नहीं आ रही है?
Yes, sir.
ठीक है, तो आपने देखा किस तरह से इनिशियल और फाइनल जो हमारे पास स्टेट्स होते हैं उनको देख के हम प्रोसेस समझ सकते हैं ना। बिल्कुल आपका कैसा एग्जांपल है, बिल्कुल लाइफ फॉर एग्जांपल। अब इसी चीज को धीरे धीरे और हम लोग क्या करेंगे, और थोड़ा इंटेंस करेंगे। ठीक है, इसके बाद सुनिए जरा, इसके बाद सुनिए। अच्छा, मान लीजिए आपके पास, चलिए ठीक है, इसके बाद हम आगे बताते हैं, किसी में नहीं मांगते। अब देर आर फ्यू डिफरेंट टाइप्स ऑफ वेरिएबल्स, है ना, कुछ वेरिएबल्स होते हैं जो कि डिपेंड करेंगे ओनली ऑन द इनिशियल स्टेट ऑफ द सिस्टम एंड द फाइनल स्टेट ऑफ द सिस्टम। ठीक है, तो इसके बारे में हम लोग आगे बात करेंगे, अभी डेफिनेशन लिख लीजिए। तो अगर हम स्टेट वेरिएबल्स की बात करें तो स्टेट वेरिएबल्स आर ऑफ टू टाइप्स, है ना, या तो उसको स्टेट वेरिएबल या फिर स्टेट फंक्शन भी बोलते हैं। तो एक होता है आपके पास स्टेट फंक्शन, स्टेट फंक्शन स्टेट फंक्शन क्या होते हैं, वो प्रॉपर्टीज दैट depends only on the initial and final state of the system। सेकंड एक होता है पाथ फंक्शन। पाथ फंक्शन क्या होता है प्लीज राइट? डिपेंड्स ऑन द वे in which process was carried out. ठीक है, अभी बिल्कुल लेमैन की तरह हम लोग थोड़ा समझ लेते हैं ना, ऐसे 10वीं क्लास के बच्चे की तरह। स्टेट फंक्शन को आप लोग याद कर सकते हैं डिस्प्लेसमेंट, राइट? इनिशियल एंड फाइनल पोजीशन, इट डिपेंड्स ओनली ऑन व्हाट? इनिशियल एंड फाइनल पोजीशन, राइट? पाथ फंक्शन यू कैन अंडरस्टैंड इट इन टर्म्स ऑफ डिस्टेंस। डिस्टेंस में क्या होता है? डिस्टेंस इट इज डिटरमाइंड बाय द पाथ दैट यू हैव टेकन। सही है हाँ या ना? अभी तक अभी उसके लिए याद करेंगे? हाँ जी बताएं। स्टेट फंक्शन एज डिस्प्लेसमेंट, पाथ फंक्शन एज डिस्टेंस। मरियम, आलिया, यासिर, सारा,
Yes, sir.
आज के लिए इतना काफी, ठीक है ना? चलो, अब इसके बाद एक छोटी सी टॉपिक है बिल्कुल, ठीक है, छोटी सी बिल्कुल छोटी सी टॉपिक है, उसको हम लिखा देते हैं, फिर हम क्लास खत्म करते हैं, ठीक है ना? प्लीज राइट थर्मोडाइनमिक प्रोसेस। ये सारे की एक्सप्लेनेशन हम लोग कर देंगे, लेकिन ये अभी लिख लीजिए जरा, ठीक है ना? थर्मोडाइनमिक, बिकॉज आफ्टर दिस आई विल ओनली हैव द एक्सप्लेनेशन पार्ट रिमेनिंग। थर्मोडाइनमिक प्रोसेस क्या होता है? थर्मोडाइनमिक प्रोसेस, अ प्रोसेस which results in process which results in process which results in change of at least one state variable. Isothermal, in isothermal process what will happen? Temperature is constant, okay? Temperature remains constant, ठीक है? B, थोड़ा हम यहाँ पे लिख दें, adiabatic process, adiabatic T is, please write, isobaric process. D is isochoric process, and E is cyclic process. Adiabatic, no exchange of heat, no exchange of heat. In isobaric process, the pressure is same, pressure remains constant. Isochoric process, the volume will remain same, volume remains constant, ठीक है? Cyclic process, after various process, system returns to initial state. After various process, system returns to initial state, ठीक है? That is cyclic. So all of these explanation will be coming tomorrow. अभी आप इसको लिख के रख लीजिए जरा, ठीक है ना? Tomorrow is very important class. Please do not miss tomorrow's class, है ना? Tomorrow's is the most important class. Okay, please don't miss tomorrow's class. ठीक है guys, चलिए. So that's it for today, है ना? Your test must be activated. If you have written this down. Assalamu alaikum, Safia. Am I audible?
Yes, sir, you're audible.
Yeah, we will just start, है ना? Give me 1 or 2 minutes. Just we will start.
Okay,
By
sir.
the way, Mariam, Sarah, sorry, Mariam, Alia, Sarah, all of you done? Done
Yes,
writing
sir.
this? Chalo. So you can start the test, है ना? Basic terminology will be the name of the assessment. Okay. Can you see that in your app? Anji. Guys, can you see that in your app?
Not till now.
Not till now. ये तो टाइम तो ज्यादा हो गया. क्लास असेसमेंट में देख रहे हैं ना? You're seeing in the class assessment, right?
Yes, sir.
Oh, it's not activated. Sure. I have messaged the team, by the way. Can somebody send me a screenshot? Safia, you guys please stay here, है ना, and stay on the app. I have asked the concerned team to check on it. Okay, I will be getting a reply. Meanwhile, somebody please send me a screenshot. Please send me a screenshot so that I can show what is happening there. Okay. So Safia, tell me what school are you in?
ISG. Yes.
Is it activated now, Alia?
Not so.
No. So just a second. ठीक है, हमने भेज दिया टीम को. ठीक है, IS से. Which class, Safia?
12th.
Oh, 12th. Okay. What chapters are done in your school? Yes, Safia.
Yes, sir, just a minute.
Sure. No problem.
So we're starting haloalkenes and haloarenes.
What chapters are done? You're starting by that, like, what something must have been done, na, Safia?
Yes, sir.
Which chapters? Just look at your syllabus or something, or your notebook maybe. Let me. If you don't know, it's fine.
We were at electrochemistry, chemical kinetics, and solutions.
वेट, अरे भाई आप भूल जाइएगा क्या? आराम आराम से बता दीजिए जरा. You understand a bit of Hindi, Safia?
Yes, sir.
Okay, you have done electrochemistry.
Solutions.
What else? Solutions. What else?
Chemical kinetics.
Chemical kinetics. Okay.
And D and F block elements.
D and F block. Fine. अब ये बताइए जिसकी वजह से आपने छुट्टी के बाद ये किया है. कब है आपका एग्जाम? When is your
March
exam?
या Feb में.
अरे भाई मार्च और फेब में तो आपका बोर्ड से, आपको बोर्ड होगा वो तो हमको पता ही है, लेकिन आपके स्कूल में भी तो होगा कुछ हाफ ईयरली
जी.
हाफ ईयरली.
जी, सितंबर अक्टूबर समथिंग मिड. एग्जैक्ट डेट नहीं आई है अभी.
एग्जैक्ट डेट नहीं आई है अभी. सो आई कैन से
सितंबर
एंड
अक्टूबर.
ऑफ सितंबर. एंड ऑफ सितंबर अगर हम बहुत लेटेस्ट मान के चले तो.
यस सर.
फाइन. चलिए तब देखते हैं आप. अच्छा बाय द वे, वेयर आर यू फ्रॉम?
आई एम फ्रॉम बिहार.
वेयर इन बिहार?
पटना.
अच्छा पटना. पटना.
यस सर.
पटना. वेयर इन पटना?
I exactly don't know that since I live in Saudi Arabia. I've not been that much to India.
So you have not been that much to India. You have born and brought up in Saudi Arabia only.
Yes, sir.
So, chaliye, let's talk about your syllabus now. See, we have done solutions chapter. Okay.
Okay.
And like, if you would have joined us before the summer vacation or in between summer vacation, it have been so good because I also did the complete backup classes of solutions. Okay.
Okay.
First thing is that. So right now, as like, I'm just not talking about too long in the future, but for short term at least, you would have to watch the lectures. Okay.
Okay.
You would have to watch. But the good thing is that we have only done we have done solutions here. Okay. Now in
Okay.
rest of my batches, I have done these chapters also. Haloalkene, haloarine, alcohol, phenol, ethers. है ना? So in all of my batches, I have at least completed haloalkene, halorine in the regular batch itself, as well as in the backup classes. Okay. So maybe for haloalkene, halorine, if we are not planning to make any, if we are going to make a new batch, then you would not have to do this haloalkene, halorine. ठीक है, but वही हम सोच रहे हैं जरा how to tackle this. How much concerned are you for the midterm of or half yearly examination that you are going to have in end of September?
I am concerned.
You are concerned. ठीक है, ठीक है, समझ गए फिर okay. That means we have to do a few chapters here now. ठीक है, so see, electrochemistry I will be doing in whatever batch I add you. I will be doing
Okay.
electrochemistry. And I will be
Okay.
doing chemical kinetics in those batch, for sure.
Okay.
है ना? These are for sure. And
Okay.
maybe see, do you have Saturday holiday? Saturday is a holiday.
Yeah, Saturday is a holiday.
Fine. तो हम क्या करेंगे फिर? Then not from this week, but from September. That is 2nd and 9th. 9th September. I'm planning to take extra classes on Saturday. Okay.
Okay.
So apart from the regular classes, there will be Saturday extra classes. So I'm planning to complete DNF block in those classes. Okay.
Okay.
Fine. So hopefully, see, there are some schools which are not giving holiday. That is a bit problem. I mean, that's slight of a problem. Okay. So, but we will continue. I think all the international schools, they are doing Saturday holiday. Okay. Another thing is that let us start with the problem that you are having in chemistry. ठीक है ना, ये chapters तो हो जाएंगे, but the main issue is the problem that you are having in chemistry. बताइए, you are having problems in numericals?
Yeah.
क्या लगता है आपको? ऐसा लगता है ना कोई चीज मिसिंग है क्वेश्चन में, कोई और एक चीज रहना चाहिए, ऐसा लगता है आपको? Something is missing in the question. What do you feel like when you see a numerical? क्या लगता है आपको? Like all the information is not given, some more information should be present. Then what I
Not
would
like
have,
that. मतलब confused जाती हूँ वो कौन से concept का है.
कौन से कंसेप्ट का है? ओके, ठीक है, यानी कि थ्योरी में, फिर न्यूमेरिकल अप्रोच में नहीं, पर आपकी पीछे फिर थ्योरी में कुछ दिक्कत है.
Yeah.
फाइन, आई अंडरस्टैंड दैट. ओके. And what chapter? Tell me. For example, have you done any chapter slightly? कुछ chapter जो आपने किया हो?
Yeah, solutions and half of electrochemistry.
You have done solutions. Fine, you have done solutions. Huh? For example, very basic question in solution would be something like this. Calculate the, I'm not teaching anything, I'm just asking like how you're approaching numericals, and I'm just seeing right now. Calculate the molality of a 10% aqueous NaOH solution. ठीक है, 10% aqueous NaOH solution, and they have given molar mass of NaOH is equal to 40. ठीक है. So how would you approach this question? Tell me. Yes, Sophia. Do you remember the formula for molality? Sophia? Do you want formula for molality, or do you remember?
Yes, sir.
You want the formula? See, so formula for molality, it is represented by small m, which is equal to number of moles of B I represent for solute divided by
Yeah.
the mass of solvent in kg. This is the basic formula for Sophia, any progress? Sophia,
Yes, sir.
tell me.
Is it like 2.77?
Can you tell me how you have done it?
Okay, so molarity is number of moles by mass, and
Mhm.
then number of moles is equal to weight of the solute by the molecular mass.
Very
So
good.
it's 10 by 40.
WB
So then we
by
get 0.25 as number of moles. Then we
10
substitute
by
this in the initial formula. So it's 0.25 by mass of solvent.
okay. You tell me. What happened? Why you stopped?
So
1
it's
by 4
9,
divided by mass of solute is how much?
9 into 10 raised to minus 3 kgs because
Wait
it's
a
90
second.
grams.
90 grams. Yeah, fine. Correct. So 90 upon 1000, right? So 1 by 4 into 90, and denominator of denominator is numerator, so it will go above like this, correct? Something like that.
Yes, sir.
Yeah, so it's our answer is 2.77. Fine. So you are able to, yeah, okay, fine. You are able to understand the questions and everything. Okay, that's good then. Okay. So you are having problems not in the basic ones, but जो थोड़े difficult होते हैं. For example, if I talk about polygative property, abnormal molar mass, in those sections you are having problem, right? Yes, Sophia.
Yes, sir.
Okay. Okay, then what we will do? Can you tell me, for example, some questions where you had difficulty?
electrochemistry, all that, limiting
Okay.
molecular and all that thing.
Limiting molar conductivity, that topic.
Yes, sir.
Okay, so this topic, I mean, it actually needs some information about the previous topic. So you know what is molar conductivity, right? You know the formula of molar conductivity? Yes, tell me.
No, sir.
No problem. You remember do you know, have idea about conductivity?
Yes, sir.
And tell me what is conductivity? So conductivity is represented by kappa, right?
Yes, sir.
kappa. हाँ जी बताएं आप. तो like whatever idea you have, आप हिंदी में ही बता दें हमें, है ना? क्या आपको आइडिया लगता है कंडक्टिविटी से? थोड़ा ऐसे ही बता दें. यानी कि क्या लगता है आपको कि नंबर ऑफ आयंस इंक्रीज करेंगे, if the number of ions increases, number of ions increases, तो कंडक्टिविटी क्या होगी, बढ़ेगी घटेगी, ये बता दीजिए मुझको आप. सफिया, नहीं आइडिया इतना. Yes, Safia, tell me. What do you think? Number of ions. If the number of ions will increase, the conductivity will also
Increases.
increase, right? Fine. And see, conductivity, it is defined by the conductance. Conductance provided by the ions in 1 centimeter cube volume. Okay. So whatever ion is present in 1 centimeter cube, it is also 1 ml. Whatever concentration, whatever ion is present in 1 ml of solution, whatever ion is present, no matter how much ion is present, whatever conductance they are bringing, that is the conductivity. Got it? Yes or no? Please tell me.
Yes, sir.
Okay, now let us move on slightly above. Molar conductivity. Molar conductivity. So if you just particular line, you can understand it is the conductivity which is provided by what? Which is provided by the 1 mole. सही है या ना बताएं? What do you think? है ना? It says already ना, conductivity, conductance or conductivity, conductance provided by 1 mole of ions. Any difficulty till here?
Yes, sir.
What difficulty? Tell me. Any difficulty or no difficulty?
No difficulty. I thought you were asking if I wrote it.
No. अच्छा, you're writing also. There's no need to write. No need to write.
Okay, okay.
अभी चल, अभी आराम से रिलैक्स समझने की कोशिश करें आप, ठीक है ना, क्या हो रहा नहीं हो रहा ऐसा, ठीक है. चलिए. Now what I can say, it is the conductance which is provided by 1 mole of a ion. Conductance which is provided by 1 mole of a ion. ध्यान से, ठीक है. Let us suppose the concentration is given as 6 mole per liter. Concentration is 6 mole
6 mole
per
per
liter.
liter.
Right. What I can say, I can say that 6 mole is present in 1 liter. सही है?
Yes.
Correct? So 1 mole is present in 1/6 liter. Correct?
Yes.
1 mole is present in 1/6 liter. So what I can say, volume occupied by occupied by 1 mole, it is equal to 1 by 6 liters, or I can say 1 by 6 into 1000 ml. सही है हाँ या ना?
Yes.
Correct? 1000 ml. Now please see. That means I can also say that whatever conductance it is provided by, this particular amount, is by 1 ml. See, lambda m will be what? The conductance that is provided by this particular amount. सही है हाँ या ना? ठीक है?
Yes.
So I can write 1000 divided by whatever the molarity is. 6 was the molarity, na? That is why we got 6 here. Correct?
Yes.
Multiplied by this 1 ml. This 1 ml will be providing the conductivity of what? Copper. Because conductance, what is K? Conductivity is the conductance provided by ions in 1 centimeter cube or 1 ml. So whatever conductance is provided by 1 ml, that will be equal to how much? Kappa. And whatever conductance is provided by this particular volume will be here. So lambda m, it is equal to what? 1000 into K divided by m. Or you can also write it K into 1000 divided by the molarity. You understood the formula, yes or no?
Yes, sir.
Okay, this is the formula. Now, after this, we can move on to the limiting molar conductance. What we can move on to? We can now move on to limiting molar conductance. Please see. From here, I can say that एक बात बताइए, lambda m, it is inversely proportional to the molarity. सही है? Correct?
Yes.
That means when the molarity will decrease, conductance will increase.
Increase.
Sorry. So let us start decreasing the molarity. How can I decrease the molarity? Means concentration, right? How can I decrease the concentration? We can decrease the concentration by diluting the solution. Correct? Yes or no?
Yes.
So we are diluting, the molar conductance is increasing. We dilute it again, the molar conductance will increase. We dilute it again, the molar conductance will increase. But there will be a point after which, even though what we are doing, we are diluting the solution, but molar conductance is not increasing, right? There will be a point now
Yes.
that will happen. So that point is the limit. That is why we call it limiting molar. And as you know, this can be written as lambda m infinity or lambda m naught also. What does this infinity and 0 means? Please see here. Infinity means that the dilution is infinite. Then also what will happen when the dilution is infinite? When the dilution is infinite, then what? Concentration will be minimum, and when the concentration is minimum, lambda m will be maximum. Sahi hai ya na? Correct, Safia?
Yes.
But what about this 0? This 0 represents the concentration or the molarity. So when molarity will be 0, then also lambda m will be highest. That is why we use both of these terms, but infinity is for dilution, not as for molarity, but they both of these things as whole means the same.
Yes, sir.
You understood what is now limiting molar conductance?
Yes, sir.
We also call it what? Limiting. It is also known as molar conductance. Molar conductance at infinite dilution. You may have heard this word, yes or no? At infinite
Yes.
dilution. है ना? ठीक है. अच्छा, अब उसके बाद आपकी ज्यादा प्रॉब्लम हो रही होगी स्ट्रॉन्ग इलेक्ट्रोलाइट, वीक इलेक्ट्रोलाइट्स में भी, राइट? That strong
Yes.
electrolyte, it increases slowly, है ना? Weak electrolyte increases. First of all, you have to understand now what is strong and what is weak. So what is strong electrolyte? Tell me. Any idea? Strong electrolyte. It gives 100% dissociation. Got it? Yes or no?
Yes.
And what about weak electrolyte? Weak electrolyte, it gives partial dissociation. Partial dissociation. Still, I'm just saying, I'm not teaching, I'm just showing you some things. That's all. Okay.
Yes, sir.
ठीक है, ठीक. Strong electrolyte 100%. मतलब आपने डाला और घुल गया. आपने डाला और क्या हो गया? घुल गया. सही है?
Yes.
वीक इलेक्ट्रोलाइट के घुलने के केस को थोड़ा सा हम बताते हैं ना. घुलने के केस को मान लीजिए you have taken 1 glass of water and you added 1 spoon sugar. ठीक है, 1 spoon sugar. ठीक है, and then you take one bucket And in one bucket also what you added 1 spoon sugar. 1 spoon sugar. What do you think where it will be dissolved easily? डालते साथ ही कहाँ पे डिसॉल्व हो जाएगा बताइए? ग्लास में,
Bucket.
बकेट में, राइट? बकेट, ठीक है. अच्छा, मतलब अगर if it is getting dissolved, if it would have been electrolyte, अगर इलेक्ट्रोलाइट होता तो वो कैसे डिसोसिएट करके ही क्या होगा? डिसॉल्व होगा, करेक्ट है? यस और नो?
Yes.
है ना? दैट मींस एक चीज हम कह सकते हैं, एक चीज कह सकते हैं कि इफ सम और शुगर जो अच्छे से डिसॉल्व होता नहीं है, राइट? अच्छे से डिसॉल्व होता नहीं, मतलब हम इसको कहते हैं डिसोसिएट नहीं हो पाता, इस तरह से बोल सकते, ठीक है ना? बट यू विल फर्दर कम टू नो शुगर इट एक्चुअली डज नॉट डिसोसिएट, वो टूट जाती है चीजों में, है ना, मॉलिक्यूल्स उसके, बट आयंस में डिसोसिएट नहीं होते हैं, लेकिन फिर भी एटलीस्ट इट इज गेटिंग डिसोसिएटेड एज मॉलिक्यूल्स आल्सो, राइट? सो लेट अस सपोज भाई,
Yeah.
ठीक है ना, तो ऑब्वियसली शुगर इज नॉट वेरी गुड एट डिसोसिएटिंग, है ना, और वी कैन से बाय इट इज नॉट वेरी गुड इन डिसॉल्विंग. But if I increase the amount of solvent की increase करने को ही क्या कहते हैं? Increase in dilution, ये बोलते हैं ना? Yes or no? Dilution is the increase in the amount of solvent. पानी ले ले, सही है सफिया?
Yes. Yes, sir.
अच्छा, अब यही चेंज आप बारे में थोड़ा सोचिएगा. You must have dissolved 1 spoon of salt in water, right? In 1 glass of water, correct?
Yes.
It instantly dissolves. Salt instantly dissolves, correct?
Yes.
What will happen in bucket? In bucket also it will be instantly dissolved, right?
Yes, sir.
There will be some difference which we can't even say, but this difference which we saw in sugar, it was huge difference that we saw in sugar. That type of difference will not be shown by salt, correct?
Yes.
है ना? तो ये देखिए, इसीलिए तो क्या होता है, सी हम लोगों ने पढ़ा है किसके हिसाब से, वी आर टॉकिंग अबाउट लिमिटिंग मोलर कंडक्टेंस, राइट? बट आप इसको मतलब डिसॉल्विंग के नेचर से भी पढ़ सकते हैं. दैट इज व्हाई व्हेन वी वर टॉकिंग अबाउट शुगर, हियर वी आर राइटिंग कंसंट्रेशन, है, रूट ऑफ कंसंट्रेशन. तो ध्यान रखिएगा, व्हाट वी आर डूइंग, वी आर डाइल्यूटिंग द सॉल्यूशन, राइट? डाइल्यूटिंग, वी आर सीइंग द इफेक्ट ऑफ डाइल्यूशन. सो वी विल स्टार्ट फ्रॉम हायर कंसंट्रेशन एंड वी विल गो दिस वे. ओके, तो सबसे पहले तो आप बात समझिए, व्हेन यू सी द ग्राफ ऑफ delta C, sorry, root C and lambda m, okay, and lambda m like this for a strong electrolyte, if you see it like this, then please remember you have to go this way, ठीक है ना? Because what is happening, I am adding more and more solvent and the lambda m is increasing. Dilution is what is happening, concentration is decreasing ना, अरे हो गया, lambda m is inversely proportional to polarity will decrease, lambda m will increase, correct है? सही है सफिया?
Yes.
अब वही चीज अगर हम देखें किसके लिए, इफ आई सी दिस थिंग फॉर दिस वाज फॉर सॉल्ट के बारे में. शुगर में क्या होगा, इफ यू आर डाइल्यूटिंग द व्हाट इज हैपनिंग, द lambda m is increasing exponentially. The change that you will see on dilution will be huge in the case of sugar, or we can say weak electrolyte. समझ में आपको सब यहाँ या ना बताएं? You understood this? Yes or no?
Yes, sir.
So that is why you have different graphs. The salt that we saw, it does, I mean, dilution of strong electrolyte does not show a large change. But when you dilute a solution that is containing weak electrolyte, obviously there will be a huge change that you will see, because the weak electrolyte, it is not dissociated initially, but as you add more and more amount of water or solvent, more and more solute particle will start dissociating. Salt में क्या था? Salt में you already dissociate 99% of the salt was already dissociated. So whatever change we saw was because of that 1% remaining. But in sugar, what was happening? Only let us suppose 30% or 40% was 30 or 40% was what dissociated. But as soon as I added water, then what happened? 60% is not dissociated. Even though the dissociation is small, 60% and 99%, you can see what's the difference. But the change is huge. Here we have huge change. 20% of change is present. Here only 1% of change. So we are not talking about absolute terms. Relatively speaking, when you dilute strong electrolyte, electrolyte, the lambda m increases slowly. The lambda m, it increases slowly. But when solution containing weak electrolyte is diluted, then the limiting molar conductance or lambda m, it increases very sharply. It increases very sharply. बात समझ में आई सब? आया ना बताए सफिया? बात समझ में आ गई?
Yes, sir.
ठीक है, अब सुनिए एक और चीज थोड़ा सा है ना, खत्म कर देंगे क्लास तो क्लास को खत्म करेंगे. If you see for strong electrolyte, if I extend this particular plot, I will reach the y-axis. This is the lambda m. सुनिएगा बिल्कुल ध्यान से. This is the lambda m when the concentration is how much, Safiya? Concentration is, यहाँ पे concentration क्या हो जाएगी? थोड़ा ध्यान देके बताएं सफिया.
Yes, sir.
Concentration is not, ये क्या हो जाएगा? यहाँ पे concentration क्या होगी बताइए this point?
0.
So this red point is the lambda m when concentration is 0, and this is nothing but lambda naught m. So for strong electrolyte, you can easily determine the lambda naught m. That means you can easily determine the limiting molar conductance. But if you try to determine the limiting molar conductance of weak electrolyte, then you will be just going on. So obviously, this particular plot, it will meet the y-axis in infinity. सही है सफिया? yes or no, please tell me. बस समझ में आ रही है? ऊपर जा रहा सफिया बताएं, ऊपर से जा रहा क्या? yes सफिया, are you there?
Yes, sir.
क्या देर क्यों लग रहा है आपको जवाब देने में? ऊपर से आ रही बातें ये समझ में आया नहीं आया? ऊपर से आ रही हो तो बता दीजिएगा, ठीक है ना? फिर हम क्लास खत्म करेंगे, कोई फायदा नहीं होगा ऐसे. जी बताएं, ये ऊपर से चला गया लैम्डा नॉट एम वाला? Yes, Safia, did you understand this? Yes or no?
So can you repeat?
अच्छा ठीक. ये we can make this much plot, correct?
Yes, sir.
Then I can extend it, right?
Yes.
Plot as a line करके. So I mean, it is just saying na, if you are diluting, then the molar conductance will increase. It will reach this point.
Yes.
At this point, the concentration is 0, right? So even the
Yes.
concentration, its molarity will be 0. Lambda m will be its maximum,
Yes.
right? So that is nothing but the limiting molar conductance, lambda naught m.
Yes.
ठीक है. So we can easily determine ना for strong electrolyte. अब बस
Yes.
कुछ particular concentrations के लिए you measure the lambda m, the molar conductance you measure for some concentration terms. You make a plot, and after making a plot, you just extend it. Once you extend it, you will get the lambda naught m. But we can't do the same thing for the weak electrolyte. You can see here. For weak
Yes.
electrolyte, what is going to happen? You have to go till infinity, right? That is why the next topic that you are going to read, आप देखेंगे, अभी नहीं पढ़ाएंगे हम, ठीक है ना? अभी तो बहुत हो गया. That is Colrosh law. Colrosh's law of independent migration or law of independent migration. This is only there to tell you about the limiting molar conductance of weak electrolyte. ठीक है? जब आप क्लास स्टार्ट कीजिएगा तब आप जब हम लोग पढ़ेंगे इलेक्ट्रोकेमिस्ट्री, then you will see how this Colrosh law, it is only used for weak electrolytes, है ना? So this is the link. The link is that we can easily determine the lambda naught m for strong electrolyte, but for weak electrolyte it is not possible. That is why we need theory. Theory is the Colrosh law. You understood whatever we studied today? Yes or no?
Yes, sir. Yes, sir.
चलिए. So अभी तो लेकिन थोड़ी वही हम थोड़ा सोचना पड़ेगा आपके बैच के बारे में, ठीक है ना?